All right, children, we are at 2.7, transitive and substitution props. We got Miss Teeter in the room here right now.
Whoop, whoop.
That's her. So, maybe we'll quiz her along the way because she loves math. She loves the transitive property almost as much as she loves the substitution property. I'll tell you what. All right, so our transitive property. So if A equals B and B equals C, then A equals C. And I'm going to go one step further because I'm crazy like that. I'm going to cross that boy off. I'm going to also say that C equals D. Then we'd have A equals D. Okay? So transitive basically allows us to link states or statements that are like equal statements, or if we have congruent statements, it'll allow us to link them from beginning to end. Okay? Don't worry about this bad boy here. So if RS equals TU and TU equals YP, then we can conclude RS equals YP. And remember, those are talking about lengths, the distance from R to S and the distance from Y to P. All right, substitution property. This can be one that's easily confused with our transitive property. So if A equals B, then you may replace A with B. So sometimes actually either one of these properties will work, but we'll try to make sure that you guys understand when you should use transitive versus substitution and not confuse the two. So here we go. We got an example. If angle 1 is complementary to angle 2, and we have this right here, which kind of floated down when it was imported into the program I use, it says that 2 is congruent to 3, angle 2 is congruent to 3. What can you conclude about 1 and 2? Well, if 2 is congruent to 3, then I can just substitute angle 3 in for 2, and I've got a new statement that would say angle 1 is complementary, comp, to angle 3. I've just substituted it in and created a new statement. Quite powerful stuff here. Probably a little bit of common sense in this one, wouldn't you think? You've done this before when you're solving using substitution for systems of equations in algebra, right? We just sub in a value. That's quite exciting. I love it. I'm so excited to apply this in a real-life situation like a proof that you'll totally use in your everyday lives moving forward. All righty, Miss Teeter just informed me that there is a shelter-in-place drill in roughly 6 minutes. Truth. So we're going to try and knock this bad boy out before we shelter in place and show our proper tornado drill form by covering our necks, right? We know that. Okay, so we've got 4 problems here. We're going to talk about which one to use, transitive or substitution. So if you look at that first one, I am linking together congruent statements. Angle X is congruent to angle Y, angle X is congruent to angle Z, Y is congruent to Z by transitive property. Although you could use substitution when we're linking together congruent statements, I would highly suggest using transitive property. Next one, angle 1 is congruent to angle 2, 2 to 3. Once again, transitive property. Substitution would also work here because we're only linking together 2, but take a look at problem number 3. If we got 1 congruent to 3, 3 congruent to 2, and 2 congruent to 4, I can say 1 and 4 are congruent by transitive property. I could use substitution, but I'd actually have to break it into a couple steps. More writing. Ain't nobody got time for that. I got bronchitis, right? So I don't have time to write all these multiple steps down. Transitive property will go all the way from 1 to 4 in one step. That is dope. Super dope. Super duper dope. Cray cray. Alrighty, next one. It says BC plus BE, the lengths, equal AD. And we have BE equals EF. Well, how could I get that proof statement? And again, we're not just doing proofs here, we're just saying what property it would be. Well, I could take EF and I could substitute it in for BE, substitution property, subs prop. Don't just put sub prop because we have subtraction, so we got to use 4 letters here. SUBS for subs, SUBT for subtraction. Aight? So that is the case where we need to use substitution property, where I'm taking something and plugging it in for another one, replacing it, right? I'm substituting it in. Excellent. All right, once again, we got some weird notations here from the import. We'll say that guy's a array once again. I think we had one of those that showed up all weird looking. So we've got FG is congruent to KJ, so these two are congruent. And then we've got GH is congruent to kj. Ooh. So I could probably use the same tick mark there, one tick mark, since I use that for kg. And I want to prove that kg bisects fh. Well, let's think about what bisecting means. Bisecting would mean I get two congruent parts, right? Well, if you look at what I've got going on here, not that it's official yet, but it looks like this segment is going to be congruent to that segment, but it's never stated here what actually happened. Well, if this guy, FG, is congruent to KJ, and GH is congruent to KJ, these two are going to be congruent to each other. And the reason I'm going to use there is transitive. Although substitution could work, we will talk about why shortly. So let's write this bad boy up. Let's see. So I can say that GH is congruent to FG. And that would be transitive property. If you wrote substitution property, that is okay. But I would stay away from that because it can lead to mistakes when we start linking more than just two congruent statements together. If you've got like 8 congruent statements that you want to link together, transitive property is the one you're going to need to use, not substitution. All right, so now how can I say that KG bisects FH? Well, KG is going to bisect FH because it splits it into two congruent parts, right? That's the definition of bisect, or the converse of that definition, because we can reverse definitions because they're awesome like that. So I can go right to my prove now. KG, ray KG, bisects FH, definition, bisect. All right, and they will start to get a little bit longer than this. We got all sorts of definitions and theorems that are coming our way. Proofs are going to start to get 4, 5, 6 steps long even, which is just so darn exciting, isn't it? Alrighty, last example here. Hopefully we can get it in the nick of time prior to sheltering in place. So I've got angle 1 is congruent to angle 2, and I want to prove that 1 is supplementary to 3. Ooh. Well, let me just throw down a little tick mark action here if my marker would work properly on here. Boom, there we go. Okay, 1 and 2 are congruent. I want to prove that 1 is supplementary to 3. Well, I got a question for you. 2 and 3 there, they look to be supplementary, yes? I'm thinking so. How do I know that? Well, I've got a straight angle, which is 180 degrees, and I know if two angles add to 180, they are sup. They know a sup, right? So I think we need to state that first. All right, so I'm going to go ahead and say angle ABC equals 180. And we'll say it's a straight angle assumed from diagram. You could put that into 2 steps. You could say angle ABC is a straight angle, and then say that it's 180 degrees by the definition of straight angle. I'm okay with this as well. Depending on your teacher, they might like a little more detail. You never know. But that'll fly with me right here. Alrighty. Well, I know that angle 2 is sup to angle 3. And keep in mind here, I didn't just say that it was a straight angle and then went to supplementary, because supplementary needs to add to 180, because those two angles might not be adjacent. So they might not be a straight angle when you put them together. They could be in totally different locations. So it's important that you say the 180 degrees there. So this would be our definition of supplementary. They add to 180. All right. Well, for my given, I believe I could take angle 1, and replace angle 2 with it, yes? Heck yeah, I could substitute it in. So angle 1 is sup to angle 3 by the substitution property. Subs prop. That is actually Jimmy John's favorite property, subs prop, because they make subs freaky fast. America. Any questions on this bad boy? Oh wait, can't ask me in the video. You just have to come to class. Be like, yo, Mr. Allen, I got a question on this vid. Alrighty, ladies and gentlemen, we have got some H-dubs here. Get that done. Ask some H-dub Qs, questions on the homework. Lots of stuff that we've covered already. All those awesome properties. One more lesson prior to the quiz. I'm sure you are quite excited for that, for the exciting conclusion of Chapter 2 in Honors Geometry. America, freedom, rock and roll.